Hi everyone, so let's do today's Leetcode question. Leetcode daily challenge. Okay, it is easy question. That's great. I can solve it quickly, I hope. Okay, 605 can place flowers. Let's do it together. I'm also looking this question for the first time, so let's go. You have a long flower bed in which I'll just keep my mobile in silent quickly. You have a long flower bed in which some of the plots are planted and some are not. However, flowers cannot be planted in adjacent plots. Um, Given an integer array flower bed containing zeros and ones, where 0 means empty and 1 means not empty, and an integer n, return if n new flowers. So 0 is empty and 1 is not empty. Okay. And return if n new flowers can be planted in the flower bed without violating the no adjacent flowers rule. Okay. Got it. So if I'm looking at this one, oh, I'm trying to copy and paste. Okay, so it means that there is a flower bed, there is a plant here, there is not plant in this plot, there is not plant in this plot, there is no plant in this plot, and there is a plant in this plot, and I need to plant one new flower, right? Because n is equal to 1. So obviously I can plant, right? And the rule is that I cannot plant adjacent. So there is a one new flower that I can plant, but I cannot plant here because this, if I plant here, then it will be near to this. I should keep a gap here, so I can plant it here, right? And the rule is not violated. The rule is that can't plant a new plant adjacent plot. Yeah, okay, so this is true. And if let's see, so in this case I need to plant two lights. So first I will plant here, and there is no place for the second plant. So yeah, so this is the problem. And flower bud length, it will be at least 1. The length will at least be 1, and flower bed it is either 0 or 1, and there are no two adjacent flowers. So in the beginning there will be no two adjacent flowers, and n can be from, so there might be no new flower as well. And so if there are no new flower, then we should just return true, right, immediately. So if n is equal to 0, if not n, then return true immediately. Only if n is greater than 1, then we should check. So for checking, what can we do? So the brute force, let's think of approach. So the brute force approach, while I was looking at this problem, that came to my mind was that I could just go linearly, right? I could just go linearly, and if n is equal to 2, then suppose if this is 0, then I could check, okay, this is not planted. Now I need to skip this. So since this is not planted, now since this is planted, so I will look at the, since this is planted, so I will look at one step forward directly. I'll not look at this number. So if this is also planted, then I will look at 2 steps directly. But if this is not planted, then I would plant here and then decrement this value. So the approach is that yeah, so I hope you understand. So I will decrement this value. What I am saying is while, so first of all, let I because I will start from I, right? So while I until I reaches flower bed dot length. So until I, so this is my traversal. So I will traverse until I reaches at the end. So I will check if flower bed I, if it is equal to 1, right? I can just say that, okay, if it is equal to 1, then what I should do is I should say I is equal to I plus 2, because I need to check for another one. Otherwise I can just otherwise it is like I if suppose here in this case, if it is 1, then I need to jump to another plot, right? But if it is not, then I can plant it, so n's value will decrease, right? otherwise do n plus n minus minus n minus minus, and here also I need to jump to another one. So what I can do is I can do this I plus plus one time, and then only if this is 0, then do this. Okay, so yeah, and look for another varied plot where I can plant, right? Because if this is 0, then n minus minus means that we plant a new plant there. So in this plot, so if it is 0, then we plant a new plant. If this is not 0 also, we will not plant. But anyway, we need to look for another valid plot, right? Until I is less than flower bed length, until we reach to the end. So when we reach to the end, n should be equal to 0. Sometimes what happens is, suppose there is 0 0 0, sometimes it might, n might reach 0 immediately, right? In this case, so we should also check, I think, while I is less than flower bed length, or n is equal to 0, or n is greater than 0, let's say. Because at this point, if n is equal to 1, and at this point okay, first of all, so suppose this is the question, then I is equal to 1 in the beginning, and we are looking at so I is equal to 0 in the beginning, and this is not valid, right? So since I is not equal to 0, so we will not do this, will not decrement n, and we will just jump over now to here at 0 position, and here I will it is like I will plant it, and n will be 0 now, and I will be equal to this position. But now I do not need to check, isn't it, anymore? So because n is already equal to 0, n is not greater than 0, so that is why I will exit from the loop. So I will return if n is greater than 0, if n is equal to 0. So if n is equal to 0, then this will return true, otherwise this will be false, right? So yeah, this is my algorithm, and the time complexity would be O of n time complexity, because in the worst case scenario, I need to explore all the flower bed, explore all the plots. I might need to look at every single plot, or actually it is n by 2, because I'm not traversing, I'm just jumping over the plot, right? So it is n by 2, and since 2 is constant, so it is O of n only. And yeah, can I do this in more efficient way? Because this is linear solution, can I do this non-linearly? I'm not sure. O of n, can I do in O of log n? No, because I need to check for every adjacent nodes, right? So after checking one, I need to check another one. Let me submit. Is there some mistake? It is not working. I think it will show time limit exceeded. Yeah. Oh, it did not work for the first question only. So first, for this one, it will be, yeah, first let me see if this is if there is any typos or not. If not, and so if n is equal to 0, if n is equal to 0, then it returns true immediately. Let I is equal to 0, and while I is less than flower bed length, or n is greater than 0, I'm doing this. If flower bed I is equal to 0, then I'm decrementing n minus minus, or I plus is equal to I plus 2, then at last return if n is equals to 0, then true, otherwise false. So I think this is fine. So in the beginning I will be at 0, and now I will be at, I'll be here, and now n will decrease to 1 because this is 0 here, right? So now I will reach here, and I is not equal, so I will, n will not decrease, and I will reach here. At this position n is equal to 1, right? So n is not equal to 0, so it should return false. 1 0 0 0. If n is equal to 2, then it will return false. Why is it not returning false? I think that conceptually this is correct, but I'm missing something. While I is less than flower bed dot length. Oh, less than. Yeah, that's fine. Like flower dot length is 1 2 3 4 5. So only if I is equal to 4, then it will allow, but if I is equal to 5, then it will not, this will not allow, right? And n is greater than 0. N should be greater than 0, n should be equal to 1 or 2, so this is fine. Oh, okay, n is greater, less than, and it should be and. I always do this kind of mistakes. This should be and, so that whenever one is true, then okay, it should be or and. So what I'm trying to do is whenever one is false, I need to return false, right? So it should be and, so that whenever this condition is false, okay, I think this will work. So whenever this, what am I doing here? In this case, if n is equal to, so what I'm trying to do here is whenever, if this is false or this is false, then this, it will be false and it will exit from the loop. If this is, both should be true to come inside the loop, right? Okay, so this is fine. And in the beginning I is at 1. Let me check this condition which is failing. So, and it will go here, so it will decrement to 1, and then it will go here and it will decrement to 0, right? So it will return true. I expect this is false. Why is it false? Oh, okay. Oh my god, I did it is 1, but I cannot even, yeah. Oh my god, I did not think of this. I was so, in relation to myself and to the viewers, each, don't don't come up the solution and be so sure of the solution. Just double check if something is remaining, to check if something, if we are missing something or not. Because here I was just I was just looking from the forward. Okay, from, if this is 1, then I was just looking at the left adjacent. I was not looking at the right adjacent, because there might be 1 here and I cannot do 1. I cannot place here, right? Because I should also look on the forward. If it is equal to 0 and flower bed I plus 1, if it is equal to 0 and flower bed I plus 1, this both should be 0, but I plus 1 might I should also check that, because sometimes, so this might be 1, and okay, when I reach here, then I plus 1 is not there, right? So if I plus 1, because I mean I might be at the end, so if I plus 1 is equal to flower bed dot length, or if one of the cases is true. So if this is true, then it will not check if it is equal to 0, because this is the boundary condition. So for this one, I is at 0, and in the beginning, first of all we will check, right, if I plus 1 is equal to, so first of all, this is equal to 0, and we'll also check if I plus 1 is equal to 0. This is not equal to 0, right? So we'll just look directly at this point, and oh, okay, it means that at every point I should also look at the back as well. So if I am here, then I should check if this is equal to 0, and back and forth both. Okay, I plus 1 is equal to, so if I minus 1 is equal to minus 1, because it means that if this is 0 and this is also 0, but if it has no anything back, right, if it is equal to I minus 1 or I minus 1 is equal to 0. So what I'm doing here is, oh, this is not or, this is and, or yeah, this is and only. So this one I'm checking if it is equal to 0 or not, if the current is 0 or not, and here I'm checking if another one is 0 or not, because to plant where somewhere, because if I want to plant here, then this would also be 0 and this both should be 0, right? Then only I can plant here. So here I'm checking if current here is equal to 0 or not, and here I'm checking if the another one, this is 0 or not, and here I'm checking if the previous one is 0 or not. So the previous one is equal to 0 or not. I mean, if it is the beginning, then there is no previous, right? So even in the beginning, it is, I can plant here. So I'm just doing I minus 1 equals to minus 1 for that. Let me check now for this one. So this is I, and there is 0, but and n is equal to 1, right? So here it is 0, and back it's true, but forward is false here. So this will return false, so this will be false, and we will go to another position. This is a 0th position, I mean this is 0, and there is adjacent on both left and right, so this will also be false, so this will be false. Now we'll look at this one, 0, this is also 1 1, so we'll look at the, oh, this position now, and means that I have to look for every position. Now this, if this is I, then because this is 1, so I will look at this position. There is also adjacent, I'll put 1 here, I mean, so I should also update it, I is equal to 1 here. Now it will work, because I'm checking, right, if it is equal to 0 or not, so I need to update it. Okay, this was not I did not do this question properly, though this was easy. I thought that okay, this is an easy problem, so I just underestimated this problem and did not think of a simple edge cases also. So instead of 0, I could just do not. I'm just trying to make my code more better, like more easy going flow. So if flower bed, if not flower bed, right, so I, and and no adjacent. So the function is, I'm just looking at adjacent. Function check if function adjacent each adjacent full. So if I'm passing I here, then this will return. So this is just for adjacent check. So this is checking if left is full or not. Constant each left full or each right. Each right adjacent plot full. Is right adjacent plot full or not, right? So this will give us, if it is equal, then true or false. And for this one, so here this will give me if flower it is empty. This will check is adjacent plane empty or not. So if it is empty, then this will return true. But if there is equal to, if it is empty, okay, I mean, yeah, so if it is empty, then it will return true. So if there is 0 here, then this will return true, right? So there is 0 here, so this expression will return true if flower bed I plus 1 is 0. Yeah, so each right adjacent plot, each left adjacent plot empty or not. And what I'll return is if both are empty, if both left and right empty. Oh, each left, why can I, okay, so this is just checking if each adjacent plots are adjacent plots empty, right? So if flower bed I, so this says that each current plot empty or not, and this looks for is adjacent plots empty or not. So if both are empty, then we will plant it, then we'll plant a new plant on this stop. Okay, so this is, I think, yeah, let's look at the solution. Single scan accepted. So this is a single scan, right? Here we are doing the similar thing here. Flower bed I is equal to 0 and boolean empty left plot. Here I'm saying right adjacent plot empty, but they are naming empty left plot. Okay, I is equal to 0 or flower bed I minus 1 is equal to 0, and empty right plot is I is equal to this one or flower bed. Okay, and if both are empty, then flower bed I is equal to 1, count plus plus, and then return if count is greater than or equal to, and okay, optimized. This is the optimized solution. What is the optimized solution? But even for the optimized solution, the time complexity is same. So how did they optimize it? Instead of finding the maximum value of count that can be obtained, we can stop the process of checking the positions of the plant as soon as the count becomes equal to n. Oh, it means that I did optimized solution here because I just checked right here. So whenever, if there are like, if flower bed has 1000 empty plots and I only need to fill one empty plant, then I can just put it in one plant, right? So in the above solution they were just checking for all the plots, even after we planted the plants that we want. So yeah, they are checking it here if count is greater than or equal to anywhere, and I checked it here. So yeah, this is my solution. Thank you for watching. And okay, the main takeaway from this solution that I did is really, really check if my solution is foolproof or not. Because even the solution is simple, if I just thought of a solution and then jumped to code quickly, then you know then it will take a longer time. Because if I just thought more after coming a solution, just thought 1-2 minutes more or a few seconds more, then I might have um, thought of the all the cases, which eventually saves a lot of time to solve the question. Okay, yeah, thank you for watching everyone. Bye.